John here. Let's talk about templates. All right, so here's a project. I have a main routine and a stack implementation that I wrote. Let's have a look and see how this stack works before we get into this stuff, right? This is the stack with no templates. I'm going to make a template out of this existing class, all right? So what does this thing do? I got a couple of private items. This pointer to an array of characters. This pointer to an array of characters here is going to be used to hold the actual stack items, the items that are in the stack. Initially, it's going to be a null. The capacity of the stack is basically how many elements this thing actually points at. The capacity, how many could be pushed in. It's the physical size of this allocated array up here. When it's null, it will be 0. The count represents the number of items that have been pushed into my array that this guy up here is pointing at, which could be 0 or more. This shall never be greater than the capacity, right? Of a constructor, there's really nothing to do because I use curly brace initialization up here. The destructor, only thing the destructor really has to do is point to the dynamically allocated buffer here, the array that holds the stack items, assuming there is one. Delete allows us to delete with a null pointer. That is legal. It simply accomplishes nothing in that case. What is this thing doing? Here's a copy constructor, right? So the only thing the copy constructor has to do is basically clone this X onto the current object, which is this pointer, right? So I wrote a little clone function that I can reuse when I implement my assignment operator as well down here. We'll see the clone in a minute. What happens in the assignment operator? Well, I want to assign this, the object, my stack that this points to. I want to replace it with the contents of the parameter over here, okay? So if I'm assigning it to myself, don't do anything at all. That just doesn't make sense anyway. I delete the current array of elements. It's going to be thrown away and replaced anyway. And once that's done, I can just call clone do the same thing I would in a copy constructor, okay? When I'm done, of course, I have to return this in order to satisfy the requirements of the assignment operator. Okay, we have a capacity count. These two items are allow us to see. These are just accessors to let us know what the current capacity and count values are of the stack object. Empty returns true if there are no items in the stack, and that's true when count equals 0. Clear says make it such that there are no elements in the stack, and it's an array of items. We don't actually have to erase them or anything like that. We can just simply set count to 0 and ignore what's in the stack because they're just characters anyway. Reserve, this says make sure that the capacity of the stack is such that it can contain at least this many items, right? Well, if I want less than the current count, I'm going to consider that an ignoring if it wants me to set the capacity smaller than the current number of elements in the stack, I'm going to consider that a silently ignored error. If I want to reserve what I already have, there's nothing to do, so I just return in those two cases. Otherwise, what do? I'm going to change my capacity to the required capacity, the requested capacity. I'm going to allocate a new array of characters here based on my new capacity, assuming, of course, that capacity is non-zero. So what do I do here? I say, if capacity is non-zero, I'm going to allocate a new array. Otherwise, I'm going to say set my temporary pointer that I'm going to use to construct all this stuff to null, right? So this will either allocate what I need or become null based on the value of capacity. That's how that is working. And then I copy, if there are any elements from the source, from the current array that the object has to this new temporary array. And when that's all done, I can delete the current array and then set the pointer to the newly allocated one. This is basically leapfrogging the data from my current array into a newly allocated one, all right? That would be the requested size. push operation. What does a push do? Well, if I'm at capacity, if the count of elements equals the maximum that I can hold right now, and the maximum is 0, I will just simply reserve enough room to hold the one I want to push. Otherwise, I will double the size, will double the capacity of the array that holds my stack. When that's all done, I will come down here and say, copy the new value into the element of the stack that represents the new top of the stack. And then, of course, I increment the count by 1. Top and pop are similar. I decided to put some assertions in here so that when I screw up and ask for the top element of a stack that's empty, I know that something bad has happened right away. That's what I'm doing here. Make sure that the count is greater than 0. If this assertion fails, it'll print this message out when I'm running. In normal circumstances, that's just simply the element at the top of the stack, right? So if there's one element in the stack, that will be the 0th element of this array. To pop something out of the stack, all I need to do is decrement count by 1. But again, I want to make sure that count is greater than 0 before I do that. And I want to be able to debug my programming easily, so I put an assertion in there for that as well. This could just as easily be done by throwing in some sort of an underflow exception or something like that. Choose what you want for your particular application. I wrote a little dump routine. What does this thing do? It prints my stack. It dumps out the capacity and the count. And then it dumps out a comma-separated list of all the elements that are in my stack from the bottom to the top. Okay, for debugging. Here's the clone I mentioned earlier. This is the same thing as the copy constructor, the body of my copy constructor, and it's a portion of the assignment operator. So what does it need to do? It needs to go off and grab the contents of a source instance of my stack and copy it to this. This variable references the instance of my stack that is the destination of the construction or the assignment. So if the source capacity is greater than 0, I need to allocate space to hold that. Otherwise, the capacity will be 0, and therefore I just make a null array pointer, and I copy the count and capacity from the source to this one. And for each element in the source, I copy it into this instance of my stack. All right. Let's look at a little test program now. Oops. This might be easier. So what am I going to do in here? I'm going to create an instance of a stack. I'm going to call my debug dump routine to see what the state is, the size, capacity, and so on. And then I'm going to do a bunch of little operations. I'm going to push an A and then dump. I'm going to push a B into my stack and then dump. I'm going to change the reserve to 2, then I'm going to change the reserve down to 1. This changing the reserve to 2 will accomplish nothing, right? Because A should have made it set to 1, B would have outgrown it, and then the reserve would have doubled it to 2. So by calling reserve 2 here, it should accomplish nothing. Calling reserve 1 should be ignored, because I've tried to make it smaller than the number of elements in there right now, right? Once I get to reserve 4, that'll grow it. So this tests a couple of different cases of my reserve function. This should grow it to 4, and we should see that in the dump. Then what do? I do push C, push D, push E, push F. Then I play around testing with top, and then I pop a bunch of times. Then I push something else, and then I call top again, and I'm done, all right? So let's compile this. And let's run this. And look at our output. Let's watch this thing go, make sure everything's okay. Here's my stack after the constructor, and there's nothing in it, in the capacity and the counter 0. That makes sense. I push an A in there. I got a count of 1. I see my A. Or push my B. You can see the reservation went up to 2, and there's 2 elements in there after that's all done. I say reserve 2. It's already 2. It accomplishes nothing. I reserve 1. It is ignored. I reserve 4. The capacity goes up to 4. We still have our elements in there, okay? We push in a C, the count goes up to 3, and we see the C added. We go to push a D, the count goes up to 4. We see the D added. We go to push E, the capacity now doubles from 4 here to 8 here, and the count went from 4 to 5, and we see the E in the stack. And you see this thing growing. It goes up to F now, and the count goes up to 6. Then what happens? We called top, and top said it got an F back from the stack, and that's great. It didn't change the state, which is nice, right? Top is supposed to tell you what's on the top, not consume it. Pop will consume the top of the stack here. So I had 8 capacity, 6 in there, and it ended with an F. And now my count went down to 5, and the F is gone. Pop again, count goes down to 4, the E goes away. Pop again, count goes to 3, the D goes away. Pop again, count goes to 2, the C goes away. I push a G, count goes back up 1 to 3. I see my G in there. I got a top. It says I got a top of G, and that's great. And I dump out the last time, and I see the capacity is right. The count and the contents of my stack match what I would expect. All right, so let's say I want to have a stack now that holds integers or floats or doubles. What would I do? How would you do that? Well, one way to do that would just be to make a copy of this file and then go into the new copy and change all the instances of the word char to double. Okay? There's only a couple in here that matter, right? Almost all this code is the same no matter what. You know, the counts and the sizes, the fact that it has an array is the same, the fact that I need to delete it when I'm done, and so on. So it turns out, how many times does that really exist in here? It's 1, 2, 3 times so far. The type of the push method matters, right? But for the most part, the code is really not that different. There's almost nothing to do here. That's it. 1, 2, 3, 4, 5, 6. That's it. There's 6 words in this entire file that need to be changed. So this would be easy. I can just make a bunch of copies of this, right? Well, as you know, as a programmer, every time you make a copy of something, you're creating a nightmare for yourself. Because if you find out, oh, there's a mistake, maybe there's a line of code that needs to be added right there. Well, now I got to go add it to every one of the copies, as well as this one, right? That's not a good idea. So it turns out that C++ has a mechanism that allows us to automatically generate all those copies, all right? And it's called a template. We can create a class using this notion of a template, and instead of hard coding the word char in here, we can say, make this itself a variable. So I can create like a meta class. So let's look and see how that would work. I can say template, and I can say type name. By convention, a lot of people just put a big T in here, especially for the simplest of templates. It's really very common to do that. Sometimes you'll also see the word class in here. Okay, you can use class or you can use the word type name. It's mostly it's interchangeable. In very esoteric situations, after like C++ 17, does it make any difference at all? Okay, so what are we going to do? I'm going to go through here and change all these instances of char to T now. So I've now parameterized the type of the data that's in this stack. Now I may need to do a little more than this, right? Because I have been mildly naive about what I've done in here, and we'll see the pitfalls in a moment. But let's see how to use this now, right? So let's go back to our main. How does that work? Well, I need to, if I can still create one, but I have to tell it what my data type is. So what you do is you put char in there. You might have seen this in some programs before. This now is exactly the same as what I had before, but when I run it, when it is used, the data type now can change. I can create a stack just as easily now of int. Let's create a stack of, in fact, let's make a stack of float All right, let's make it down here. All right, so let's leave all the code we had alone up there. So that's still legal for testing out my stack of characters, right? Because when I was pushing characters like this, okay? And now let's say push, 27.3225 or whatever, right? Into, I don't want to make that one S. I want to make that one, let's call it F. Because I already have an S, right? This one was called S up here. I gotta give it a new name. So I can push a floating point number into this stack if I want to. I can say f.dump, just like you saw before. I can say, what do I want to do? C standard out like this. And I can say I'm calling top. Oops. And the results of the top call from F look like that. We put an end of line on here. Okay, and of course we can pop. And we can dump again. The stack should then be empty, right? So let's compile this one. All right, great. I did very tiny amount of work, and now I have two different stacks that are basically being created out of the same code. So look what's happening down here. Here's the end of the, remember the top, I should print something else out down there, make this a little bit more obvious. Like maybe I'll say a bunch of asterisks in there. Separate the two things. Okay, here we go. Now I've got a stack. This is my float one down here. Here's my character. Remember the top G and the push G at the end of the sequence of interacting with a character stack. Now I have a stack. And remember I called dump after I pushed one element into it. So the capacity and the count is 1. There's the value I pushed into it. That's the top, gives me a floating point value. I then called pop and I dumped it out again. And I got that. So just to make sure that we're all, let's push a couple of items in here. Let's push in, 33, 44, 55, and so on like this, right? All right, and there you can see, and there's more stuff in there, right? And top again works. It grabs the element off the end of the stack. Now, for a huge number of cases of using templates, everything you just saw is all you really need to know. This is the vast majority of cases in addressing the simple case. I've got a class whose data types are all welded to some, an int or a float, and I want another one. Well, what do? Well, you do exactly what I just did here. You parameterize the one type that's important, and you change it to that. All right? You say, I'm going to declare a thing that represents the type. I'm going to use that instead of hard coding it. All right? Now, of course, it can get ugly if you don't really consider what you're doing. What if the elements in your stack cannot be manipulated using the code you wrote? And by that, I mean things like this. Look what's going on down here. When I make the reserve and I decide to throw away an array, and then I want to create this new one here and copy all these items, right? I need to be able to execute this assignment operator. Now, if it's a character or an int, then this is, an int being assigned a new value given by this int over here. But what if it's a complex object? What you need to do is keep in mind that these objects need to be assignable. All right, you need to have an assignment operator, or the class has to be simple so that the default assignment that just copies the member fields works. Okay, you also want to be careful when you do a delete. If you remember, this is an array up here. If you don't put these square brackets in here and you delete your array, the destructor on all those elements will not be called if these square brackets are not in here, okay? That could become a problem. You know, if it's a simple plain old data or an int or a double or a float, it doesn't matter because they don't even have destructors, right? But if you decide to create a stack of some complex object that has, you know, a dynamic state or something in there, dynamically allocated variables on the heap, you better invoke all the destructors to get rid of all those things that are being pointed to in there, right? Again, we've got the assignment operator, not a problem. The top, yes, this should be fine. That should be fine. It doesn't really do much either. Now look what's going on down here. In my dump routine, I've got C out, double left arrow, and then a value of an instance of the thing in my stack. Well, the C out, the standard library, already knows how to use the insertion operator with an int or a float or all, you know, the common data types. But again, if I create a stack of some foo item, something I invented myself, this code won't compile unless I provide a friend function that knows how to provide this service here. Okay? If you go to compile this and it dies, that's what's going on. I'll show you that in a minute. When I'm cloning, I'm not sure that there's anything interesting in here that we haven't already talked about. We've got to be able to assign the thing. And again, new is going to work anyway, right? So you've got a couple of items in here that we need to concern ourselves with. Don't be lax and sloppy in here, is the bottom line. If you delete P array, make sure you don't do this, okay? Don't remove those square brackets, all right? This is now more useful, is what I'm saying here. All right, so let's say I create my own class foo. It's got an element in it, a private member called I. I've got a constructor that allows me to set the I value, and I print out it's been entered and on its constructor and its destructor. All right. So let's say I want to create a stack of those. All right. Now remember, I need to be able to assign these values. I got to be able to copy them. I need to be able to use the insertion operator and everything else on them. And I didn't do that. Okay, so this is the kind of thing you're gonna see if you don't provide everything you're supposed to. Let's call it J because I already used F. There's my stack, and then let's say what? I'm gonna say J.push. Maybe I'll push a new foo whose value is 4. This will probably get me into enough trouble as it is. Let's go ahead and call JDump. All right, let's see what's going to happen here. All right, oodles of errors. Oh my gosh, look at all these things. Lots and lots and lots and lots. I've got to wonder if I mistyped something. No match for operator insert. So this means the dump routine, you recognize this line of code here, okay? It doesn't know how to print this element of the array. It doesn't know how to print what? A foo, okay? I don't know how to do this, okay? I don't know how to print a foo. I didn't provide a friend that implements this thing right here, and it tells you need to do one of these guys, okay? And that's just all because of that. All right, let's go ahead and remove my attempt to dump this, right? If I comment this out, it turns out if I don't call that function, I won't have this problem when it compiles. But there's still other problems that have here. Like, for example, in the reserve function, it says, I don't know how to do this when t equals foo and so on. I don't know how to do the reserve. Well, what's wrong with my reserve? Look what's going on here. I need... What do I need? I say, look, I cannot call new on foo. I cannot create an array of foo objects. And the reason I cannot do that is because I didn't provide a constructor. The default constructor doesn't exist. It won't allow me to create one of these. Let's do this. Let's give this a default value. So if anybody constructs a foo and does not provide this argument, it will have one to satisfy that situation, right? All right, now we're cooking. We can now allocate one. We still cannot print it. All right, we still have this problem. Let's just not dump it for the sake of testing here, just for fun, right? You got work to do is my point here. So let's now call j.push. What do I want to, I already did a push for, okay? So let's say j cout less than. If I say j.top right now, this won't work either. This is the same problem that that dump has, right? This line of code here won't work because I'm trying to print out something. I'm trying to use the insertion operator on something that it does not understand how to do. Let's call this get. Let's add a member function here. Int get return. All right, now this allows me, if I want to get the value of that I and print it out, I can do so because JTop returns me the element. It gives me a reference to the value that's at the top of my stack, which is a foo with a 4 in it. So this will print out that 4 or not. Passing const foo discards qualifiers. Oh, yes, okay. This has to be a const function. There we go. So look what's going on here. Oh, badness. Foo entered. Here's two constructors. A destructor is called. There's the 4. Then there's a destructor. And then, oh my God. So this thing is going nuts here. Well, we've discovered a bug in my implementation. So he's doing some bad stuff here. So my theory is I screwed up something, possibly in my destructor here. So let's look at my stack. I mean, it has to be a bad delete somewhere, right? Well, obviously, this one here is not right because I forgot, after all my going on about putting the square brackets in there, I forgot one. So let's just look at every occurrence of delete in here and see if there's anything odd going on here. All right. These all have the square brackets. They all say P array. And P array, it's not possible to construct an instance of my stack where this has garbage in it because of the curly brace initializer. That's one of the benefits of this, right? If I meant to put it in here and I didn't, I'd screw up. I think these are really great for self-documenting code because I know for a fact if all I'm going to do is hard code them to some value in the constructor anyway, they're really nice to see them right here when I define these members, all right? So that's great. My point is this can never actually accidentally be left with garbage in there. Let's make sure there's nothing else going on that's weird. It might be that my argument that it's okay to delete null, which I happen to know is absolutely legal, it might be that that belief is incorrect. But I know that that's correct. I know that's true. So I'll bet anything that's the problem. Let's see what's going on here. Let's go ahead and run it now. Of course, it runs fine. And that does beg the question, how come I constructed 2 and destructed 2? Why is there one constructed and then destructed immediately, right? Let's take another look at main and what's going on there. So what do? I say, look, my stack foo, when I push one instance of foo in there. So by doing this, I construct one. I construct an instance of foo and I call push on it. Later on, I grab it out and I print it out. It might be that this requires it to make a temporary copy or something like that, right? So let's test that theory. Let's not do that, right? Let's run it again. Well, that rules that out. I'm still constructing 2 and destructing 2. And it'd be nice to know for sure what's going on here, right? Because the problem is if you construct things unnecessarily and they're big and they're complicated and time-consuming tasks to make copies, you know, if you have a deep copy, it might be a 400 billion element tree or something in this stack. You don't want to do it unnecessarily. So let's look at what else are we doing? I'm getting ahead of myself here. So the only other thing I'm doing is I've constructed. I know I've constructed one here for sure. Okay, I've pushed it into my stack. What happens when we do a push? Well, remember, this is the very first time I ever call push. It turns out I am at my capacity because capacity is currently 0, count is currently 0. It goes in here, it needs to reserve a space for 1, and we already looked and see what happened when we didn't have the proper constructor. We know dang well that reserve, when he says new T here, every one of the elements in this array need to be constructed at the time that this array has been created, right? So this is my second constructor that gets called. And then I make a copy of all the old elements to the new ones. It turns out this loop doesn't run the first time here because the current count is 0, right? It was my first push, so there's nothing to copy. So this will not get done. The old array is deleted, that doesn't exist, so that's a delete on null pointer, and the new array is remembered by assigning the p array pointer to the newly allocated array. All right, so we go back to push now and see what happens in here. Well, what happens in here is I'm using the assignment operator on my foo class. Now, I didn't write an assignment operator, but it'll use the default one, which is to simply do a member-wise copy of the object. In my case, that's fine. It just has an int in there, and it's perfectly fine to use the default assignment operator. So that actually is why we have 2 that were constructed. The one that I constructed in order to pass it to the push function, and the one that was constructed here in this stack, all right? And to prove that, let's then call reserve. Let's just call reserve once up here, right? So let's go j.reserve. Let's reserve 4. Oh, there's too many 4s in this program. Let's reserve 2, all right? So I think what's going to happen here is it's going to construct 2 things. Let's print something so we can trap it, and we know that that's what's happened in there. Okay, after reserve 2. All right, how do you learn stuff? You got to write these little tester programs. Okay, then we're going to push some stuff in there, and then we're going to print out the top using this screwy method here, okay? Let's compile it again. Let's run it now. Okay, so what happens here after the stack? This is the double stuff. I should have probably printed another set of asterisks right here. Okay, there we go. Now compile it, run it again. All right, fine. Here's my playing around with doubles or floats or whatever we were doing there. Now, I've created and I've done a reserve of 2. Here's my little message, all right? So this, yes, definitely, it's because he did new foo, because foo is the type of the template, and he allocated an array of 2 of them, and they needed to be constructed. So there they are. They've been constructed. I then print out, hey, this is after my reservation. I now see a foo be constructed and then destructed. This is the foo right here. It has that 4 in it right there. Let's go ahead and print out when we say this. This was just foolish not to do this in the first place. Let's print out the I value. Right? I mean, think about what you're doing when you create your debug code. You can see how annoying it is that I'm not printing out things, enough information about what I've done here, right? Now when it prints the constructor, it says, oh, the value that I was passed as a parameter is a 0. So then it calls reserve. Clearly now this is the foo with the 4 in it that is constructed in order to be passed into the push when the push call is done, the temporary object that I created right here is destructed before I proceed down to print this out down here, right? Which calls top. And because top returns a reference to the foo in the stack itself, it doesn't construct a new one as a result of calling top. If I changed top and returned an element by value, you would see another one get constructed in here. This is why you need to keep your wits about you when you're thinking about, should I return a reference to something? Should I return the value of something? You know, how much work are you asking the compiler to do on your behalf? You might argue, oh, it doesn't make any difference. But if you want your program to finish before we all die of old age, it would be nice for you to design out any unnecessary copying of objects, okay? So what's going on over here? Well, these two things that are destructed, you'll see a 0 and a 4 get destructed. Well, what's happening there is, when we get to the bottom of the main here, remember we're in the middle of main, this function right here, okay? When this my stack foo goes out of scope, it's destructed. Well, what does the destructor for my stack do, right? It does this. It says delete all the elements in my P array. Well, remember I reserved 2. There were 2 of them that were constructed, right? When I delete them all, it prints out down here every element that gets destructed. During the destruction, it says, hi, I'm Mr. Foo, and I have my I value was set to this. So what we can see in there makes perfect sense. It deletes the foo with a 0 in it, and it needs to delete the foo with a 4 in it. This is somewhat insightful as to what the compiler decided to do here. The element with 0, the last one in the array, is deleted before element 0 is deleted. It's weird. It did them backwards. And do not for one moment think that this has anything to do with the fact that we have a stack in our data structure that's a LIFO structure. No, this is a feature of the compiler. I don't know if they all do the same thing or not, but that's just an interesting side note. It's deleting the last one, the nth element of the array, before it deletes the first element of the array. All right, let's get back to what we were doing before here. I would like to be able to do the dump routine, right? Remember, this doesn't work correctly right now. It didn't compile, right? And it couldn't compile because it didn't know how to use the insertion operator on an instance of my class. So I compensated by cheesing out and writing a little get routine down here and hard coding it, and I had this commented out. Now let's make sure that this works just like all the other types. Now this is not a problem with my stack per se. It's a problem with my foo class. If I'm going to create a class and I want to put it in my generic stack, and I want to be able to use the dump routine, I have to be able to provide a proper implementation for an overloaded operator in here, right? So how do I do that? Well, I have to, first of all, I got to include OStream. Then I have to provide a proper implementation of an operator overload. I have to do this as a friend function, right? Because the left side operator is not a foo, it's some other data type. So I have to implement this as a friend, okay? So let's go ahead and write that. How does that work, right? You have your OStream on the left-hand side, and on the right-hand side is your instance of foo here. Now I can, because he's a friend, I can do this, reach in there and print it as an int. So this is really all I need to do. I also have to, when I'm done, return the proper return type, right? So now the cout, the insertion operator knows, it'll search for this friend function to figure out, how do I deal with a foo? How do I print a foo? he'll just call this guy, and this guy will just reach in the foo, grab the int value, and print that int out, okay? So now this should all compile, and remember I removed my get. I even commented it out up here to make sure that no one sneaks in there and tries to call it. And, of course, I didn't do it right. What did I do? I put a single colon after one of my namespace prefixes. Now is a good time. Okay. All right, now let's see what happens. Woohoo! Now we're cooking. So it worked. Here's my dump routine. Here's the capacity is 2. The count is 1. This works great now. So now I can push foos in. Let's put a 4 and a 7. And, yep. Accidentally hit Q. Let's put a 12 in there just for yucks, right? So let's make that. Now, we see an awful lot of constructors and destructors going on in here, right? We already talked about this before. Every time I push something in, I have to create one temporarily so that it can be copied into my stack. So there's a 4, there's the 7, and here's the 12, all right? Now notice that when I push the 12 in there, this is the first time I go beyond 2. My reserve 2 was good enough for the 4 and the 7, and now when I go to 12, it has to allocate a whole new array with double the number of elements. And because it's using the default constructor, they're all set to 0. Then I between this line of code and that one is the loop where it copies the values of these 3 into the new stack over here. Then the other one, the old array is deleted. Actually, that's these 2 being deleted. Then my push function returns, and my temporarily created 12 is deleted that goes along with this one. And then the very next line of code is dump. So the capacity went from 2 to 4. There's 3 items in there, and they're 4, 7, and 12. These 3 items are printed out using my overloaded friend operator. I then call top, and then I leave the scope, and again, the whole stack is deleted. And of course, again, we see it deleting all the items in backwards order, which is again an artifact of the compiler. I'm not sure that's a specifically required ordering that's stated in this C++ specification somewhere, or if that's just an artifact of the compiler that I'm using, which happens to be G++. Either way, it still does what it says it does. If I put the square brackets, it says it will call the destructor of every element in that array. So that's an introduction to using templates and classes, along with some of the pitfalls that you can run into depending on how your code is written in your classes, right? Always be mindful about the context within which your templated class could be used later on. See you next time.